Good morning, scholars. Okay, so today we're going to be going over representing proportional relationships. Remember, we've done proportional relationships before. This is such a great opportunity and review. We talked about what proportional relationships are, but for those that forgot, let's go ahead and just review it a little bit. So, whenever we talk about being proportional, we're talking about that the scale factor or the slope is the same. Like in the graph, the slope will always be the same. So how do we find our slope? Remember, our slope is m equals, and we can do for proportional linear equations, all we have to do is take the y over the x. And if we do that for each one in the table, our result should be the same number that lets us know it's proportional. So for example, here we said we have y, which is 6, x is 4. So y over x, so 6 over 4. This can be simplified to, they have 2 in common, so 3 over 2. So I can just write under it 3/2. And I will do the same thing for the other ones to ensure the proportionality. So you can even make your own category of y over x. What else do we know about proportional? For proportional problems, we know that y equals mx is the way that the equation will be set up. Whatever we find for our slope is what goes here for the m. Once you discover if this is proportional by finding the slope and if they all equals 3/2, then you need to figure out what does 3/2 represent if I don't see it here. So I might have to put it in a decimal form. So that's something you will have to do. So go ahead and pause the video and do number 1. Okay, thank you for coming back. We're going to work and talk about number 2. Which table shows the same relationship between x and y as the graph below? Well, for problems like this, what I like to do is to look at to see what kind of answer options I'm being given. I'm given tables with x and y points. So because of this graph, I can do 2 things. One, remember before we talked about we can find the slope. I can do that. I can find the slope of this line and then find the slope of each one of these options. That's one way. So I'm going to say 1, I can find slope of graph and tables. The second way, which is the way I'm going to use, I can just find ordered pairs. So what does that mean? That means that on this graph, I can use my x because remember, our x are independent. So I can use my x to see if I get the same y's that these graphs give me. So when I look at number 1, I go up here. It is a little bit past, it's here. It's a little bit past according to the y-axis, a little bit past the 1/2. So I see I have a lot of fractions. If I'm not good with fractions, I would rather turn those into decimals so that I can be more comfortable. So for example, there's a 3/2. So there's a 2, 1, 1. Well, this one doesn't have it for the x being 1, but these have for x being 1. So I can check to see if one of these will work. But let me tell you what I do. I like to look along the X and see if there's any time that my X is touching the graph at a whole number. Wow, it is right here at 3, 5. And so I then will go and look if I can see 3, 5. 3 is my X and 5 is my whole for number 2. And that should help me narrow down my answer choices. But you go ahead and you can convert some of the fractions to decimals if you need to, like this 1 and a little bit above the 1/2. You can convert that to see what is, which one comes close to that. Pause the video and do number 2. Thank you for coming back. Okay, so for number 3, I want us to look at what it's saying. It says a helicopter is at ground level. So ground level tells me it's at 0. And it rises into the air at a constant speed. Constant speed lets me know I'm dealing with proportional, because anytime I hear the words like constant speed, I'm thinking M equals, not M, Y equals mx, because it's using constant speed. After 5 seconds, the height of the helicopter is 40 meters. The helicopter continued to rise at the same rate. So the rate is not going to change and it keeps rising. So again, same rate that leads to proportional, but we're still going to check that. Which table shows the relationship between the time in seconds X and the height of the helicopter in meters? Well, what I would do is I will make my own table, because they give us table options. So a table is probably going to be the best way to solve this type of problem. So when I make my table, I have to think about that X is seconds. I'll bring it up here. Seconds. And Y is meters. Now remember, when we talk about being proportional, one thing we did not make mention of is that anytime that something is proportional, whenever X is 0, Y is also 0. So I'm going to add that onto our chart, because we said we started on ground level 0 inside of the equation, the problem. So that lets me know that it is going to be 0, 0. Then they give us additional numbers. They said 5 seconds is when the helicopter is 40 meters. So at 5 seconds, the helicopter is 40 meters. Because this is proportional, I'm going to use proportions to find the rest of my points, because I need more points. So again, we're going to use our x-axis because they're independent numbers. And we're going to try to find the points for 10, 20, and you can pick one more number if you like. I would say 40. Why not? So I'm going to set up the first one, and then you're going to keep going, and then you're going to solve number 3. Okay, so to set up a proportion, you might remember that first I'm going to say, because meters go over seconds. Why is that? Because that's our Y over our X. So they gave us this information right here. That's what I'm going to use as always my starting base. So I have 40 meters over 5 seconds. Don't get tricked. Do not make the mistake of flipping the order, because we're not talking about 5 meters to 40 seconds. We're talking about 40 meters to 5 seconds. Now that I have that, I'm going to use one of my X, 10, and place it here. Once I place it here, because it's a second, I need to find out how many meters. The best way sometimes is to use what's called the scale factor. 5 times what will give me 10? 5 times 2 will give me 10. If I do it to the denominator, like the equal sign, I have to do it to the numerator. So 40 times 2 will give me 80. So I'll set up another one, meters over seconds equal 40 over 5. I'll say equal, and then I'm going to set it up for 20. I'll have to write this in my graph, 80. I'm going to stop and pause now so that you can continue filling in your chart and answer number 3. After you're done answering number 3, I want you to go ahead and continue to do the next 3 problems that all are still part of independent practice, and they follow suit with the 3 problems that we just did together.